Lesson 12.6, Permutations and Combinations. Our essential question is, what is the difference between a permutation and a combination? Our first new vocab word is a factorial. A factorial is a symbol that looks just like an exclamation point. So n factorial means the number of ways that you may arrange n items. So the number of different ways that you may arrange a certain amount of items. The fundamental counting principle is our next vocab word. What that means is multiplying the number of choices at each stage to get the total number of combinations that you could make. So multiplying the number of choices at each stage, so you're going to take all of those numbers and multiply them together to get the total number of combinations that you can make for something. Our third vocab word is permutation. The notation for a permutation is a capital P and then in parentheses n comma r, and what it's equal to is n factorial divided by n minus r factorial. With a permutation, the order matters. The n represents the total number of things that you're talking about, and then the r represents how many you're using. So like for example, in a class with 30 students, maybe I am going to use 3 students from my class and give them like some sort of an award, like first place, second place, and third place in a spelling bee. So the n would represent 30 because there's 30 students in my class. The r would represent 3 because only 3 of them are being selected. And the order would matter because I would be giving them something different for first prize, second prize, and third prize. A combination, the notation looks very similar to a permutation. The denominator is different though. The denominator has an r factorial being multiplied by the n minus r factorial. And the order does not matter in a combination. So a combination is different from a permutation because a permutation is a situation in which order matters. The order matters, like first place, second place, third place, gold medal, silver medal, bronze medal, or like finishing a race, the order matters, or a phone number, a locker combination, all of those things where the order that you do something matters. Combinations, when the order doesn't matter, that's like if you are going to have a bowl of ice cream and you're going to have a couple different scoops, different flavors, or a pizza with a couple different toppings. It doesn't matter what order they really put the toppings on the pizza, or the order that they put the scoops of ice cream in your bowl. That doesn't matter. Okay, so let's try these out. Factorials first. Lloyd and 5 of his friends go to a movie. In how many different ways can they sit together in a row of 6 empty seats? Well, there's 6 empty seats. Lloyd and 5 of his friends, there's 6 people. So 6 factorial. What 6 factorial means is 6 times 5 times 4 times 3 times 2 times 1. A factorial, when you solve a factorial, you always start with the number that's next to the factorial symbol, and then you work your way down to the number 1, and you multiply them all together. You can think of it like this. The first seat in the first empty seat, there are 6 people that could sit in that seat. So one of them sits down. The next seat, there are only 5 people that could sit in that one because somebody's already sitting in the first seat. You keep on going with this pattern. The third seat, there's 4 people left, then 3, then 2, then there's just the last person who has to sit in the last seat. So if you multiply all of these together, and you can even use this key on your calculator. A lot of calculators have a factorial key. So if you see a key on your calculator with an exclamation point, you can go ahead and use it. But if we multiply these all together, I get 720 ways that those 6 people could sit in 6 empty seats. So it's a really large number, probably way larger than you expected, because you think that there's only 6 people, that there couldn't be that many ways, but there really are. Now the next one, how many different batting orders can Tommy's coach make if there are 13 players on his team? Well, 13 factorial is going to be 13 times 12 times 11 times 10, and so on. So this one is a huge number, 622,702,0800. So look at all of the different batting orders that Tommy's coach could make. Because in pitch ball, you all get to bat. So you use all 13 of those kids in your batting order. So that's over 6 billion batting orders he can make. Okay, now the multiplication counting principle is very similar to the idea behind a factorial, where you're using multiplication and how many choices there are. But a little bit differently would be thinking about, our first one says, how many different outfits can you make if you have 5 pair of shoes, 3 pair of pants, and 10 shirts? So the multiplication counting principle, or the fundamental counting principle, says that if you analyze how many choices you have at each stage, you can multiply them together to find the total number of combinations. So like with the factorial, where I was saying you have 6 people to choose from for the first seat, then 5 for the second seat in the row, and then 4 for the third seat. This, we have 5 pair of shoes to choose from, we have 3 pair of pants to choose from, and 10 shirts to choose from. So we multiply those together, and there are 150 different ways that you could wear a pair of shoes, pair of pants, and a shirt. So outfits, 150 different outfits. The next one says a new car comes in 6 different colors with 3 types of engines and 2 different transmissions. So how many different cars can be made? So 6 colors, 3 types of engines, and 2 different transmissions. So 6 times 3 is 18, times 2 is 36. So 36 different cars could be made. All right, now let's start working with some permutations and combinations. So permutation, if I flip back to the beginning, you can see that permutation formula. So n factorial, n minus r factorial. So I'm going to show you how to do this, n comma r. So n is the total number of items, and r is how many we're going to use. So 7 minus 2. Okay, so 7 factorial means 7 times 6 times 5, and so on. And 7 minus 2 factorial is the same as 5 factorial. So look at what happens if I simplify without actually calculating the 7 factorial and the 5 factorial. I can see that all that would be left is 7 times 6, or 42. You would get the same answer if you multiplied it all out on your calculator. You would just get really large numbers to use. If you've got the factorial key, it makes it easier. So you can use the factorial key if you've got one, but you don't need one. This next one, we have 9 items, and we're using 3. So 9 factorial divided by 9 minus 3 factorial. So 9 factorial divided by 6 factorial. So you can see where they start to overlap is at the 6. So all of these they have in common. So I really only need to do 9 times 8 times 7, or 504. Next, we have some combinations. Remember, the combination formula looked like a permutation formula, but then they threw in an r factorial in the denominator. So 6 factorial divided by 6 minus 4 factorial times 4 factorial. And 6 minus 4 factorial is 2 factorial. So if I expand this one, 6, 5, 4, 3, 2, 1, And then 2 factorial is 2 times 1. 4 factorial though, 4 times 3 times 2 times 1. So these cancel out, and then I can reduce 6 divided by 2 is 3. So what happens here is I'm left with 3 times 5 or 15. 15 combinations. Now, permutations typically give you large numbers. Combinations are much smaller than permutations because you're dividing by an additional factor on the bottom of the fraction. So that makes your answer smaller. One more combination. So 5 factorial, 5 minus 2 factorial, and then 2 factorial, N and R. So 5, 4, 3, 2, 1. 5 factorial is the same as 3 factorial, so 3, 2, 1, and then 2, 1. Cancel out. 3, 2, 1, and 3, 2, 1. And 4 divided by 2 is 2. So 5 times 2 is 10. Much smaller numbers for combinations. All right, now, combination or permutation, because not all of your problems are just going to be giving you that notation with the C and the P and telling you what N and R represent. You're going to have to be able to read some situations and determine if it's a combination or a permutation and then calculate it. So a locker combination. Does a locker combination involve having an order that matters? Absolutely. If you put the numbers in the wrong order, your locker's not going to open. So order matters. Order matters for this one. So that means that it is a permutation. Permutation is when order matters. A phone number, absolutely order matters on a phone number. Putting toppings on a pizza? No, that order doesn't matter. If they put on pepperoni and then mushrooms or mushrooms and pepperoni, it doesn't matter. Or sausage and pepperoni, pepperoni, sausage, doesn't matter. That's just a combination. Internet password, absolutely the order matters. Choosing 2 students to run an errand? No, it doesn't matter. If you're choosing 2, it doesn't matter which one you choose first. They're both going to run an errand, the same thing. So you have to ask yourself if order matters. If order matters, it's a permutation, a permutation. If order does not matter and you're just combining things together, that's a combination. Okay, you should be able to write a summary now and check with your teacher to find out your homework problems for the day.